Welcome to the series on DBMS tutorial. In this series of part 2 we will be understanding DBMS normalization forms. Normalization is the process of organizing the data and attributes. It is performed to reduce data redundancy and ensure data is stored logically. Data redundancy means having same data at multiple places. Different normalization forms. There are 6 different normalization forms. First normal form, second normal form, third normal form, BOYCA that is Boyce Codd normal form, fourth normal form, and fifth normal form. Data relation in first normal form is a single value attribute or it should not contain multi-valued or composite attribute. Let's take an example to understand clearly. In the table we have 3 columns, namely ID, name, contact. So as per the one normal form, no column value should contain multiple values. But in the table, contact for the ID 10 in the first row is multivalued, which does not satisfy the 1NF. So to satisfy the one normal form for the data we need to split the multivalued attribute data that is contact to different row. The multivalued column of ID 10 in the first row is now split into 2 different rows. That is highlighted in yellow color. Second normal form. In second normal form the data format should satisfy 1NF and should eliminate partial dependencies on the other columns. In the table we have employee ID, project ID, employee name, project name. The data in the table have partial dependencies, like employee name can be determined by employee ID and project name can be determined by project ID, so here it is violating second NF rule as it is having partial dependencies. To satisfy the second NF rule, we need to split the data like employee table containing employee ID, employee name, employee project table containing employee ID, project ID, and project table containing project ID, project name to satisfy 2NF along with 1NF properties. The relations in 2NF are clearly less redundant than relations in 1NF. However, the decomposed relations may still suffer from one or more anomalies due to the transitive dependency. Third normal form. Data will be in 3NF when it satisfies 2NF and there should not be any transitive dependencies. A functional dependency x to z is said to be transitive if the following 3 functional dependencies hold: x to y, y does not to x, y to z. If a transitive dependency exists, we can divide the table to remove the transitively dependent attributes and place them to a new table along with a copy. For example, let's consider a table containing employee ID, employee zip code, employee name, employee city. The above table is not in 3NF because it has employee ID to employee city transitive dependency because employee ID to employee zip code to employee city also. Employee zip code is not a super key and employee city is not a prime attribute. To remove transitive dependency from this table and normalize it into the third normal form, we can decompose the above table in 2 tables. Boyce Codd normal form. This is the advanced version of 3NF. Let's directly understand the example. We have a table containing employee ID, project leader. The table satisfies all the normal forms till 3NF, but it violates the rules of BCNF because the candidate key of the above table is employee ID, project ID. For the non-trivial functional dependency, project leader to project ID is a prime attribute but project leader is a non-prime attribute. This is not allowed in BCNF. So we have converted the employee project table into BCNF by decomposing it into employee project and project-led tables. Fourth normal form. A relation R is in 4NF if it is in BCNF and there is no non-trivial multivalued dependency. For a dependency A to B, if for a single value of A, multiple values of B exist, then the relation will be a multi-valued dependency. Let's consider an example. In this table we have employee ID, project leader. Here in the data, employee ID to project ID, employee ID to project leader.
Both are non-trivial multi-valued dependency.
The given relation is in BCNF, since no functional dependency exists. But the above table is not in 4NF. To satisfy the 4NF, we need to decompose the table in 2 steps. Now, employee ID to project ID is trivial multi-valued dependency, since employee ID union project ID equals employee project is in 4NF. Employee ID to project leader is trivial multi-valued dependency, since employee ID union project leader equals employee project leader. Fifth normal form, 5NF. A relation in the DBMS is in the fifth normal form if it is in the fourth normal form and does not consist of any join dependency.
The joining must also be lossless for this.
Fifth normal form is satisfied when all the tables present in the DBMS are broken down into as many more tables as possible to ensure that there is no redundancy. Consider an example. The table contains the data of employee ID, project leader, project name. Data employee ID 100 is tagged 2 project leaders with 2 different project names. So in case we need to add new project with project leader for the employee, there will data redundancy and 5NF comes into picture. So the data in the table to be designed to 2 different sets. Employee ID, project leader, and project leader, project name.